I will give somewhere in the talk a bit of demo with live coding or the live coding. So if it is too small, then at that moment, please move forward, but just see what happens. Good, let's get started. So my talk today is about weaponizing and hardening GitHub Actions. I think we have seen over the last year quite a serious amount of supply chain attacks related to GitHub Actions, and I think it's time to talk about this and to see on how we can do better. And what is better than start with seeing how things can go wrong? So let's start with that. So who's using GitHub? Okay, so that is at least something I don't have to explain that much. So in GitHub you have something very nice. You can make issues, like in all systems sometimes called tickets, and you can say something here like, hello NDC, let's start. So we make an issue, that's it. We are very lazy, so no content provided. And so this is just a simple issue. And what is nice about GitHub, it can automate things related to issues. So at this moment, an automation process is running, hopefully, and you never know. GitHub has problems this morning. So yeah, it's running. And you see, it reads my title and makes some nice comment. And you can do all kinds of nice things with those automations. And since the fact it reads clearly the title, let's see if we can do something a little bit more malicious. So we update the title and do script injection, and we let them just tell you, there's a nice bash script, let's try to get it into my action. The bash script will do something like this. It is doing, let's say, a kind of malicious stuff, not so scary at this moment. And we see it's already executing, and boom. We have the secret out of the repository. We know what kind of permissions we can misuse. And when we look to the files, we see also 2 files are just right now created at this moment. So I have the secret and I have access to the main branch. Boom. That is what can go wrong if you make small mistakes. So for my talk today, I use quite a lot of slides. I hope I get through them. They are all behind this QR code. I will show the QR code in the end. Links to demos are also here, so feel free to scan it or scan it later. You can make pictures during the talk as well. It's up to you, but there's no need. Everything is online and will stay there as long GitHub is online. Good. My name is Niek. I work as principal engineer for Philips. That's a company in the Netherlands. That's enough about me, because today it's about the software supply chain and how can we make this stronger. So let's level a little bit on the software supply chain. It's in general a couple of components. We have our source code, that's a source code system, in most cases Git. We have our build systems. Today we will heavily look to GitHub Actions, but the same principles apply to any other build system. We have registries where we store our artifacts, and from that we deploy our systems. And of course, we have also other systems interacting with those systems, like a developer endpoint or an AI agent. But in general, these are the main components in the software supply chain. And in the software supply chain, we have seen over the last year quite some serious attacks. Who knows the ZX attack? Yeah? No, that was a very, very scary one. That was an attack on a compression library that is used under the hood in OpenSSH that, let's say, almost made it all the way in all the Linux distributions in the world. Can imagine that you have a Trojan horse in all the Linux servers that's running our full internet in the world. This came just to the supply chain by a very well-designed attack that was social engineering for over 2 years. There's another level of attack than the other 3 attacks that we see here. Those are just misusing weaknesses to get into the system in the pipelines, and that spread also through the supply chain. So spreading to the supply chain is the same. It's of course not the type. The other 3 attacks I will show during the talk in a bit more detail. GitHub Actions, who's using that? Oh, okay, skip the next slide. No, so to ensure that everyone is on the same page, we do it very, very quickly. GitHub Actions is the ecosystem in GitHub to do CI/CD. It's an automation workflow system that can act on most events in the GitHub ecosystem to run automated workflows. Workflows you define in code. like I did with the issue I was showing in the beginning. So the workflow is in code. It's defined in jobs and steps. And every job is running in isolation on a runner. That is a piece of compute, either managed by GitHub or yourself. So that is a very short introduction to GitHub Actions. A workflow looks typical like this. So we tell on the first part, on line 1, on what event it needs to trigger. In this case, the pull request or the push. But the demo in the beginning was based on the issue. Then we tell which runner it needs to use. In fact, we tell you something, I think it's better explainable, like these are the capabilities I need. So I need a runner with capability Ubuntu latest, and then I get that runner. So you typically not say, I want to have that runner. No, you say the capabilities, and then GitHub is distributing your workflow to a runner matching that property. If you have one, it goes obviously to that runner, but if it are many, you never know where it runs. Then we have a GitHub checkout action. That's a third-party component, like an open source component that we pull in our workflow and we run in our trusted environment when we work the workflow. This is a component that is cloning the repository managed, maintained by GitHub, but it can be any open source component, like you do with all the open source third-party dependencies. Next steps are just running our scripts. In this case, it's npm, but it could be anything. Anything that runs on Ubuntu runner and the software is available. So no matter what you think you want to run, you can run it there. Good. So a little bit recap. So GitHub Action Runners, it's an ecosystem for CI/CD, heavily built in Lego bricks, as I called. So the actions are the Lego bricks of your CI/CD, and you can stitch them together and to build a composite workflow. You have runtimes to run on, Node, Docker, or the native shell. You have different types of runners, Windows, Mac, and Linux. And so you can build everything together. And we use it everywhere today, I think. No matter if you use it in your companies or, let's say, in open source, we use GitHub Actions to test our software, to validate our software, to build our software, to distribute our software, to make a release, to generate documentation, to run a deployment to the cloud. I think everything a developer can think about to automate, he can do through the workflow. And I've seen the most crazy things. That has nothing to do with software development anymore. But they think, oh, it's like, they literally use it like Amazon laptop, but it's so easy, it is there, I run it there. So if you can automate it, you can run it here. So that's an awesome system. And it's also an interesting system to weaponize. And that's where the things can go wrong. And why it is so interesting? Yeah, because we can run everything. We run everything there. And we run there very powerful processes with a lot of, let's say, system access. Let's think about that. If you build a release, your software release for an open source package or in your company, and you need to publish the release to a registry, that is an important credential that you most likely need, or access role. Being able to get in that process and maybe change that process and put something in that release that does not belong there, that is interesting. In many cases, we have many secrets around there. The question is, do we need them? But there are many secrets there typically. Get them out to the system and do, let's say, more malicious things for them is, from an attack perspective, very interesting. When you use it in your companies, maybe your code is also value to you. Maybe it has your secret algorithms. They are also interesting to get. And it happens, eh? It is truly interesting. So there's a lot of interesting stuff, and typical your CI/CD system has access. Let's have a look on a little bit more bigger workflow. And in this workflow, we use a couple of actions. And so we see we use the TG action change files for version 45. So, yeah, if you start searching on the internet and you want to do something with changing files in your workflow, you typically find examples like this. And this looks in general quite good. So this is what happens. And also if you ask an LLM to make a workflow like this is what you get. And this workflow has a problem, because the version 45 is not locked. I get just the latest version 45. So I never know what I get. And if that version gets malicious, the latest one, I get automatically the malicious version. So what I can do here is pin to a certain version. And then this looks maybe good, but that means I really need to know maybe a bit about the internals or read all the documentation, which I don't do. Because I'm not locked to a version in this case, it's just a git tag. And the git tag is mutable in most cases. Yeah, GitHub is fixing a bit of that, but still most actions out there are based on the git tag and is mutable. That means if an attacker gets access to that repository, he can change that tag. And that what happened last year in the attack that we know now as the TG action attack. An attacker could gain access to the repository, was able to mutate the tag, create a malicious release, remove all the old tags, and point them all to the new malicious tag. So no matter if you use v45 in this case, or a specific version, at the moment the workflow starts running, it is pulling the sources from GitHub, the action, and boom. And in this case, this attack was done actively hunting for secrets in the workflow and print them in the workflow log. So this attack was scary for open source projects, maybe less scary for companies where it is closed. But for an open source projects, for many projects, their NPM tokens were just visible in the workflows. So this problem has a simple solution. You can pin your action not on the version, but on the git SHA. And that is not so readable, yes, but this is the only way to do it safe. Because in this way, you point truly to a specific version in Git, and this can never be changed, or let's say almost never. Who is pinning to SHA versions? Who? Okay, quite a few people. But if you look on any example on the internet, this is not what you find. If you ask an LLM to do it, you don't get this. So it's again, you need to practice this, do this, or have safeguards in place to enforce that you're doing this. Dependabot, a tool that can update your dependencies, can manage those SHA versions, so they can update them for you, and also updates then the commands that are more human readable on the back. And that brings me back to the open source third-party components. Those components we get from the internet, they have maybe transitive dependencies. At the moment you put something in your workflow, it's your job to think about what do you trust. I've seen people that pull in complex actions that do nothing more than you can do with one line of GQ. So just one JSON query. Why do you need 50 dependencies for that with all the risks? And you can do it with one single line. So it's also the responsibility that you think about what you pull in your system, and you scan that and you vet it. And so that is the third-party dependencies. It's here with your pipelines, but it is with all the things you do related to software development, of course, so it's not unique. Another example. So in this example, what can go wrong? This example comes literally from a real attack. So what we see here is we have a workflow that is acting on a discussion. It takes some user input. You see it in the run. It takes user input from the body, and it is pushing that in the shell. So there is no sanitizing here. So I would say it's obvious that that can go wrong. And remember the talk that we had this morning, the keynote. What was the first thing that always goes wrong, the thing that goes most wrong? Input validation. Exactly here. The issue thing that I was showing is exactly this pattern. This can lead to people are able to run scripts on your systems, or even worse, when you have a self-hosted runner set up a reverse code execution point, a reverse shell, for example. This can go easily wrong, and this happens continuously. And so script injection is dangerous. Shai-Hulud attack used this, for example. So if you have seen that attack last year, I go in a bit more detail on the attack. This was using also, the example here is coming from this attack. So this example was actively used by the attackers to set up remote code execution points. And user input it's everywhere. If you start looking on the GitHub events that are there that have user input, there are quite a lot. I put some of them on the slide, but don't read them all. Just look them up in the documentation. But even the branch name, the branch name can be defined by the user. And there are attacks there that use the branch name they are able, via the branch name, to do injection. Because you interpreted the branch name without sanitizing it. So again, user input. Now, this is a thing that we easily can avoid by sanitizing the user input to an environment variable. So what we do here is we not directly feed the user input into our command, but we funnel it to an environment variable. And with this pattern, we ensure that the input is sanitized. And when we take the example from the beginning and we rewrite it a little bit, in this way we can do it safe. It's maybe useless, but it is safe. Good. Here we have another example. And now it becomes, I think, slowly a little bit more complicated. But in this example, the event is pull request and pull request target. And pull request target is interesting when you use a fork. Who's aware what the forks are in GitHub? A little bit. Okay, good. So when you have in GitHub, you have open source repositories and you want to contribute to a repository, which is a quite nice behavior. So you make a fork of that repository that's actually a copy in your user space, and you can make your changes to that fork. And then you can open a pull request back to the origin repository to say to bring your contribution back as a good citizen of open source. But an attacker can also do that and use that point to inject malicious things back to the origin project. With pull request target, the change that is proposed coming from an untrusted source, the forked repository, is running in the context of the trusted repository, and dus the origin repository. And that has access to, for example, tokens or secrets that you otherwise won't have. So you can use this in a safe way, but in general you have to be very sensitive on how to use it. Hey? Use it in such a way that it have no access to those kind of things. Ensure that no user input get interpreted in any way. And that is what happens here. There goes user input in, and boom. And it is literally this example that is the origin of most attacks that we have seen over the last year, as far as I know. So most attacks were started in some way with this pattern. Also the singularity attack. So this attack was an attack on the NX ecosystem, which is one of the popular Java build systems, the NPM build, the JavaScript NPM build systems. So when you do multi-module JavaScript, this is a very interesting ecosystem to use. Now that's nice. And it is used a lot, so be able by make this system vulnerable, and developers continue pulling in the latest version because they like the latest. You spread very quickly. And there was some script hidden by an attacker in this library, and also the VS Code plugin, that starts actively looking for secrets. So remember from the keynote this morning, identities. So you pull in this NX malicious library, it starts searching for secrets on your system. It was even using AI, so it was looking, hey, do you have Amazon Q installed, or Gemini, or I think Claude, something like 3. And then start those kind of agents with a flag like YOLO, so no questions asked, because that's much better. And then use that system to find secrets on the system. I've tried it out, the prompt. Now, the only thing you want to do is hit cancel, because it looks very, very scary. But this was all caused by the pull request target, and ends up in this way. Yeah, that was already explained. Is this? So the pull request target problem is still there. GitHub did a couple of things to make it harder to use it. That was introduced on December the 8th. Guess what? One of the last big attacks that we have seen, Shai-Hulud, was 1 week before this. So maybe also another reason why they fired that attack, I don't know. Could also be Black Friday, because it was also the week before. But this problem is still there. And that we saw also in the beginning of this week when Step Security published an article where attackers made a kind of claw bot that was crawling over open source repositories to find repositories having those patterns not used in a wide way. So they are dependent on pull request target with user input. And then this LLM was nicely crafting, I guess, code to get into those repositories. And some bigger open source projects got attacked last week. Meaning all the releases were wiped out at some moment, all of them. Complete repository takeover. Just pull request target. And you can't say last week, I didn't know that. Because we have seen it over the last year again and again and again. And still happens. So enough about the pull request target. If you don't understand it, don't use it. And if you understand it, think about how to avoid it, because if I see those kind of things about pull request target, I get even nervous, and I also use it somewhere. But be very carefully. The cache, and cache is great for developers. As a developer, you want to have speedy builds. You don't want to wait. And the cache is a typical way to speed up builds. In some way, it's an anti-pattern because you have a problem and you want to masquerade it, so you use a cache. But it speeds up your build, so it's great. But a cache is sometimes also shared. And that is also a point for attackers to get into your cache. And also here, it is that also GitHub and those systems are making those caches stronger and stronger. And the same problem also was in GitLab years ago. I don't know where those guys are standing today, but the cache is a way to get into the system. So when you have important workflows, the one thing that I want to mention here is, if you have important workflows like releasing packages to NPM or running your CI/CD to deploy to a cloud system with a lot of permissions, don't use the cache, just disable it. Because it is only a dangerous point that people can get into your system. And for those workflows, those speed is typically not so important. On developer branches, where things should be speedy, you don't want to have those kind of credentials there for deploying with admin to the cloud, publishing to NPM. They should not be there. So maybe there the cache is not a big risk. But on those important workflows where you release, avoid the cache. Let's move on to how we get access to other systems, or in the system itself. So GitHub did here actually a quite nice thing. They introduced the GitHub token, which gets injected by default in your workflows with secret GitHub token. And what is here very nice is the token is short-lived. So if you work for terminate in a normal way, the token gets invalidated at the end of the workflow. So even if someone get that token in his hands, it is very short-lived. That's a good thing. The bad thing is, by default, because I think it started in that way, this token is read and write. So it has a lot of read and write access to APIs from your GitHub repository, because the token is scoped only to the repository. That's all a good thing. So you cannot use this token from one repository to call another repository, but in your repository, that token can, for example, write files. It is this token that I used in that issue example in the beginning to create the files. So that token is powerful, and by default injected with too much privileges. And by having that, we can do things like writing files to our branch, depending on how we lock branches, but that's another topic. What we can do much better here is define in a very descriptive way what the permission should be. So we define the exact scope that we need. And we start here on top with defining that we need, we say by default we don't want to have any scope. So we get a token injected in the workflow that has no scope. That means, I think, the most minimal scope that's possible. So that is something called metadata. And then in the workflow job, and there can be multiple jobs, we tell exactly what token is needed. This could also be a reason to sometimes think about how big a job should be. And sometimes you see jobs that enormous length. That means tokens in those jobs are also exposed to every process in that job. And so with important processes, you can think about make this job scope small and define the token that you exactly need. And that gives you a way to move in a direction with clear boundaries and minimal privileged access. We are not always lucky that we use a token. Sometimes we have to deal with long-lived tokens. When it comes to cloud tokens and GitHub, you should not use them. So that's the one thing that you should take out from here. So when you deploy to cloud, Amazon, Google, Azure, I guess Ali, you don't need to have secrets, but you still see them a lot. And for some systems, you need secrets. The problem is, of course, if you leak them for some reason, the blast radius is high. It's long-lived. So the moment it is leaked, you have a problem till the time you have it revoked, and the whole window in between, you are at risk. And we can avoid that by using OIDC, which is OpenID Connect. And that gives us a way to have a short-lived token injected in our workflow based on a trust relationship. So what we do here is we define between two systems, GitHub Actions, and in this case, Amazon Cloud. But see Amazon Cloud as an example. It could be any other cloud. We define a relation of trust. So we define conditions under which we say we can set up a trust relationship. And then it is incredibly important that think very well about what conditions do you want there. Do you want to trust anything in GitHub, specific repository, or maybe even more specific in a GitHub repository? So this trust relationship, then, if that is a match, in this case the OIDC provider in Amazon generates then a short-lived token and send that back, and that token will be then used in the workflow to do calls to Amazon. The same is also working for several registries today, like Artifactory. I think also NPN is supporting this. I thought it is now supported. So what we see is we're moving more in this direction, avoiding that we need to have all those long-lived secrets. No matter if we use secrets or OIDC, we have to think about, again, our trust boundaries. How do we protect our secrets? How do we ensure that only the right identity or in the right situation, the OIDC trust can be obtained? And with GitHub Actions, you can use environments to only grant secrets to that environment. If you don't do that by default, if you define a secret in the GitHub secret store, it's available to every workflow job in your repository. That means any branch, anything. So everyone with right access to your repository can get all the secrets out. Everything. Also, Shai-Hulud used this. And with OIDC, it's a bit the same. You define a trust relationship, but if you define a trust relationship on repository level, or even worse, on organizational level, everyone in that organization or everyone in that repository can obtain that role to your cloud. And since it is always very hard to define minimal privileges also in the cloud, it's much easier to use the admin role because it simply works. It also simply works for an attacker. So again here, patterns like wildcards, don't use them. Be very explicit and think about what is the scope you need, who has access to the repository, how are your boundaries. And you can also solve things by who has right access to your repository, but it is an area where you have to think about how to balance that. And when you use it open source, you have to take much more care because everyone has in some way access to your repository. Good. Brings me to the Shai-Hulud attack, which I already mentioned a couple of times. So I think this attack was quite well crafted from, let's say, if you look how it was well done. I think they still missed a couple of things, but I would say props for those attackers. Not nice for us, but for them, they did it very well. It started here on top with pull request target. So pull request target and user input, that was how they infected patient, let's say call it patient 0. So again, it started with user input. And that first victim, that called the script injected, that leads that it calls a malicious Shai-Hulud script, the payload, that is let's say the virus or whatever it is, in that package, and everyone that is putting that package could automatically install this package via the npm post install, and it starts running. And that happens in this phase. So you put it in, and it starts running. The first thing it did is looking, hey, is this maybe another npm package with an npm token? Nice. Then I can also copy myself, put myself in that npm package, and publish a new version to npm with that package. So I warm. This result that I think in 2 days, 700 npm packages were malicious. So that went very fast, and quite a lot of very popular ones. The next thing it does, it starts actively hunting for secrets in all kinds of ways. So finding identities to give an attacker access to systems. So it looks for cloud secrets if they are there. And if there are cloud secrets, that's already nice to have, but those cloud secrets were also then used to find, hey, can I maybe go into the Amazon secret store and extract secrets, or can I go in other vaults in Azure or Google and get the secrets out? Boom. It used, if there was a GitHub pet token, it used that GitHub pet token to create a workflow that was extracting the secrets from the GitHub secret store. So it just makes a workflow, get all the secrets out, boom. What else did? Oh yeah, other nice thing. There are tools to protect yourself from getting secrets in your source code, like Git leaks and trufflehug. Nice tools. And because if you have secrets in your source code, it's a problem, and it can be everywhere in old commits. So they were downloading trufflehug and running trufflehug on your place to find, hey, are there any secrets? And get them out. They were looking for a GitHub pet token, as I already mentioned. They were downloading the GitHub Action Runner, so they installed the GitHub Action Runner on the system here, download the GitHub Action Runner, use the pet token to create a workflow in the public repository, the discussion one I was showing, and then you have a remote code execution endpoint. So the attacker could go into your system. And then, of course, they look for pet token, GitHub pet token, look if it is there or not. If it was not there, they look it up on another GitHub open source repository and use that token to exfiltrate all the data to a public GitHub repository. So there all your secrets goes out. So your cloud keys, whatever was found, boom, up the internet, on the internet. And that happens to an enormous amount of companies, an enormous amount of repositories, and an enormous amount of secrets were leaked, including a lot of active GitHub tokens, of course, because it was a GitHub close to GitHub ecosystem. A lot of cloud tokens, active ones, but it was not only running on GitHub, this attack, it was also Jenkins, Azure, DevOps, GitLab CI, all those systems were impacted. And also developer endpoints, of course. But the blast rate seems to be the highest on GitHub Actions because it is most likely the most used system. So, I think that was already enough about all kinds of attacks. I think it's time to think about how can we do it better? How can we make our systems more resilient? How can we harden them? And we've talked about quite some patterns, like how do we lock and pin proper our actions? How do we define scope for our secrets? What else did we do? Dangerous triggers like pull request tags, all those kind of patterns. I explained you for some of them how to avoid them, how to solve them, but then you have to know it. How can we do this in an automated way? How can we protect ourselves, our teams in a better way? There we can do a couple of things through configuration. So one of the things you can do on the GitHub side is on enterprise, organizational, or repository, you can define rules for which GitHub actions you allow or which you don't allow. So an allow or deny list. You can force here sharp pinning, And you can say, you can configure that the token that gets injected is only a read-only token and not a read and write token. Something you can do on enterprise organization and repository level. This is configuration-wise. You can pull in GitHub Advanced Security, which is paid for private repositories and free for open source. And GitHub Advanced Security can help you to get better insights in your third-party dependencies with a dependency review action. And you can also configure that action to block certain things getting into your system. And based on OpenSF scorecard, you can put a workflow in place based on CodeQL that scans your GitHub workflow actions for malicious patterns. Several of them I've shown before. And there are also open source tools if you want to stay on an open source side more. Sysmore, I think, is the most interesting tool to use here, and that is what I will show that tool in the next slides. Sysmore is a very advanced solution to harden your workflows, and you can choose the level on which you want to harden. So you can set certain levels, you can configure rules that are important for you. You can make exceptions for certain situations, so it's highly configurable. We have checkoff that scans a very basic level. ActionLint is actually not checking for security at all, but is checking for issue workflow, let's say more or less executable. It's more standard linter. I see sometimes confusion on that. So Sysmore is a CLI that you can run to scan your workflows for secure patterns. And you can give them different personas to check for different type of things that are important to you. You can configure it, you can put it in your workflows with an action, what we will do shortly in the demo. And of course, you can enable it in VS Code as a plugin. So that is Sysmore. It's a very nice tool to check out. Good. I will demo this. The demo is on this GitHub repository. Let's move to that demo. Good. Good. What we go to do here is we have a repository. It has some standard code and some standard builds available. And what we go to do here is to harden this repository with Sysmore. So the first thing we do is adding a workflow with Sysmore to the repository that is checking in our CI/CD if there are problems. So after we have this in our workflow, in the next PRs, we will see clearly if problems get introduced, and now we start already actively scanning for problems. So this is the tool Sysmore that is helping us with this. We go to add another workflow, and that is for the dependency review, and that is the other thing that was shown. This requires, by the way, GitHub Advanced Security, but it's open source, so I can use it freely. And this is checking my open source third-party dependencies. So we're adding this to GitHub, and we open in the PR, so we can see what's happening. See, we open the PR. There it goes. Yeah, good. So this is my PR with the code that was quickly written for us here. So we see here the PR, and we see that already the dependency review is running, and we see here the Sysmore is already failing, and we can check here the annotations, we can check the workflow, and we can also enable Sysmore for GitHub Advanced Security, and then you get nice commands in your workflow because then it supports fully the GitHub ecosystem. I go to so what I not mentioned very explicit here is it starts warning me here about the cooldown, and that is not actually the workflow, but it is dependable. I've used dependable to keep automatically my third-party dependencies up to date, and I've used, of course, the standard configuration that I get back from typical GitHub Copilot or whoever gives me it. And that standard configuration is just running dependable, maybe daily or weekly, and it updates just with the latest. So if I'm running on an unlucky moment, I get directly a vulnerable dependency in my in my system. And quite common advice is, since the last attacks of last year, is at least implement a cooldown period. So wait several days, suggested 7 days, to update your systems. So that is what is asked here. So maybe that's good as first thing to implement. So we add simply a cooldown period to our dependables configuration file, and we add it to GitHub. And next, Sysmore will run, and this warning will go away. We not go to check this in detail in GitHub. We can do that. We can come back there later. We can run Sysmore locally, like we do here, and this gives us all the problems that Sysmore is seeing at the moment, and things that we also need to solve. One thing that is still clearly here is the GitHub actions that are not pinned. So my actions are not pinned. They are using just some v whatever version, because simple. So the next thing I go to do is to pin all my actions. I go to put the SHA here in place, and I do that for all the actions. So I would advise, if you do this, and you should do it, put a command with the version in behind. Nice thing, if you put a command with the version behind the SHA, and you run Sysmore, and it is the SHA and the version in the command is not matching, it also fails. It says, not good. So even if you make there a mistake, it warns you. So we have made these changes, they are pushed. And if we now go back to GitHub, let's go back to the pure. It's most likely still failing. It's running. Yeah, it fails. So we have still some more problems to solve. We go to solve them step by step. But we have problems with permissions. There's another topic that we covered in the talk. So permissions in the workflow is another thing that we have to define. And that's what we do next. So we run Sysmore. Again, we see, okay, we have problems with permissions. Let's fix them. And that is that we have to define the permissions for workflows and for jobs that we tell exactly what type of token we need. And of course, you can, let's see if this is working. Good. So as I mentioned earlier, so here we say permissions, no permissions on the workflow. I think that's the best practice to do. And then on job level, we tell exactly what we need. So we need to write the pull request in this case, and we need to read the content. We update that, and we push that to GitHub. And we run Sysmore. And we run Sysmore in a not so strict mode here. So at this moment, Sysmore says, okay, you're good to go. Are we really good to go is what we will find out in our workflow, because our pipeline is the true. The user can always trick you. So the pipeline is the real true. And the pipeline says no. So there are still problems. And now we come a little bit to the nitty-gritty detail. But the problems are here too. One, it is a good practice to define concurrency limits in your workflow to get overloaded, for example. And another thing is, when you add those permissions to your workflow, it's a good habit to tell why do you need them. Explain the next person coming to your system that he understands why are these permissions needed. Because at some moment in the future, you have no clue anymore why you put the permissions there. So let's fix the last part. So we run Sysmore again, and we run it now in full pandemic mode. It also is checking actively online if the actions I'm using are vulnerable. So if there are vulnerables known, that also will block them, and it tells me that I have to do 2 more things, as I was already showing, like defining or make a command why those permissions are needed. So we add here the commands to the permission, and we add the concurrency limit. And with that, in this very simple example, we have solved most of our problem. Yeah, and we push the code. So I assume if we go now to, we run sysmore locally, of course. Yeah, now everything okay. And I assume that our pipeline should now be happy. Yeah. Oh. Oh, this is our test. We were already there. It's time for drinks. Good. So our workflows are now all fine, and we have now a proper protection layer in place. We could do quite a lot of the same work with CodeQL, but CodeQL does not go to this level of detail. So I think sysmore is still, I think, the most advanced solution out there, and of course it is open source, what I personally like very much. Let's go back here. Main. So we go back to the main branch. We open our AI. Who is using GitHub Copilot or Claude, for example? Okay, so you think already this guy is crazy, do everything by the hand. We caught it then, but still, indeed. So what you can do, if you know exactly the pattern that you do, and it's maybe not perfect, but you can write exactly what I did and explained. Everything I did, you can write down in a markdown document for a skill and explain what you want to do. And we can make a workflow hardening skill, and we can run that. And this skill is also aware of sysmore, knows to use sysmore, what kind of patterns are like. I've written down it in the skill. And this is then trying to harden my workflows. Problem here is it is AI, it's not deterministic. But I ran it I made it last week, I ran it a couple of times. And most cases it was fine, it was not perfect. But this is a direction on which you can enable yourself to even make this simpler to implement the first time. When you have it in place, it's not hard to maintain those practices anymore. But especially if you come from an area where there is nothing, this can truly help to enable you. And it will ask, of course, to run all kinds of scripts, and I simply click allow. But this is what you can do with skills, for example. You find the whole ID back in my GitHub account, if you like so. Good. We let AI play here a bit around, and we go back to the presentation. So I mentioned already a couple of other initiatives that are interesting in this whole area. So OpenSSF Scorecard is, I think, a very interesting project to check out. It gives you much better understanding on how well are those third-party dependencies maintained, managed, but also how their pipelines and their security is done. So it is also scoring based on patterns in the pipelines. So a project with very poor pipelines, no pinning, no permissions defined, and so on, gets a very low score on that topic. So OpenSSF Scorecard is looking to several of those topics and then gives over the end scoring. The Salsa framework is an interesting framework about supply chain security to think about where do you want to stand, and it looks on, of course, all the aspects and not only where we're looking today. And GitHub attestation is an interesting way for signing your artifacts based on Sigstore. It works out of the box, I would say. If you have nothing else in place for signing and you use GitHub, I think it's a very easy way to go. So let's boil this back a bit to, let's say, standard patterns. And it's nothing new what I'm telling here. It's just we should think about what are the boundaries of trust and how do we apply them in the pipeline. Do we make one big job that gives access to everything, and do we use a system that's running for a very long time? Or do we make build systems that are ephemeral, short-lived, short jobs with minimal privileged access combined? Gives us a much safer way to run our workflows. We have also to think about the other layers of security to bring in place. What do we scan? What do we check? Defense in depth. And last but certainly not least, always think about the input that goes into your system. Huh? Your input is untrusted in general. Yeah. So I thought when I had this talk, how can I speak here without talking about AI? That's not possible today anymore. I think the next time you can place AI here and leave me at home. But AI agents are going fast. And I have not to explain this, but our world is changing very quickly. We're using AI for a lot of things. I started, I think, 3 years ago with a little bit of a chat. I thought, or it was not even chat, it was code completion someday. No, that was already a bit nice, and then it came chat, and then it becomes a bit of agent, and now we are somewhere what they call level 2 agents. So we give already a lot of trust to those agents. And that trust already is misused, for example, an attack 2 weeks ago, where with AI, an AI agent open source repository was attacked, and via the npm post install, they installed on victims OpenClaw. Now that's a nice system to run on your system, I think. So it's real, and this was, I think, it was not a very big attack, and there's not a lot of, I think, almost no damage. But I think it's a wake-up call how fast our things are going and how dangerous it can go in this way. And I think what we all know with AI, what takes us typical days or hours goes in AI's seconds. And also the attack with the Purus target that was calling just the open source repository to find victims. Yeah, as a human we don't do that, but put a bot in your place that just you tell the patterns and go out and go wild. There you go. And when we use AI in our own systems with, let's say, AI-assisted coding, AI agents, I think we have really to think about how do we use them? What kind of permission do we give? Do we bring agents in a place where the developer is, give all the access that the developer has, and then, yeah, we have allow, but we get lazy, allow all. Our tokens are just our tokens, give access to everything, full access to system, all our GitHub repositories. What can go wrong? And if it goes wrong, it goes terrible wrong. So we should think, in my opinion, in a way that we put those things more in a sandbox. Can we not place them in an environment that is safe, that we can say, okay, go wild. What's the worst thing that go wrong? Because you are in your cage, and at some moment I have to say, okay, this is okay, and then it goes through. But should I give it all the permissions? And that is today still a problem, because in general you have not much options just to give you your user permissions. There was a nice talk earlier this morning about MCP, where the same problem with MCP tools. You just give your permissions. It should tool-based scoped. But that's not where we in general standing. So I think this is a very interesting topic to check out. A lot of topics not covered, and it's just to mention them. I think there's 2 things that I clearly want to point out here quickly is when you run your own GitHub hosted runners, it's not simple. It's not simple to scale. It's also not simple to secure them. And when you run them as long-lived machines, and you have an infection on one machine, it can spread through your whole ecosystem, of course. So when you run them, think about how to run them ephemeral. One job, one runner. Workflows, shared or template workflows, not sure how they mentioned today, but they are very nice, but they are also an easy way to make simple mistakes. For example, pushing all your securities up to other workflows, secrets in other workflows. So think very carefully about those workflows. As mentioned, you can find everything back online. Slides are there, demos are there. Yeah, I would say for tonight there are, I think, some drinks, but tomorrow start securing your repositories. Add those practices to your repository. Run for the fun a tool like Sysmore or CodeQL workflow on your repository and see what it tells you. And you will see it's quite simple to fix. Put an agent behind this. The agent will work it out for you. With that, I think I'm almost out of time. Thank you for the attention so late on the day. Questions? Any questions, or do you all want to go to the drinks? No? Was it clear? Okay, no, that's good. Thanks. Otherwise, I will be around and this opinion.